Okay, in this video, we're going to do a two-dimensional projectile motion problem where we have to find the time. And in this particular type of problem, the math gets a little bit trickier than in some of the other projectile motion problems. So let's go ahead and jump into it. We have an object being launched from a cannon on the ground with an initial velocity of 52.0 meters per second at an angle of 42 degrees from the horizontal. It lands on the roof of a shed that is 3 meters high. And we want to know how long the object is in the air. So the reason this one is a little bit more difficult is because the object is not landing at the same height that it's been launched at. So we can't just say delta y equals 0 and then easily solve for the time. So let's go ahead and draw a picture of what we have and write out our given values. So we have our ground here and our little cannon, an object that's being launched out. It'll go to some maximum height, but then before hitting the ground, it is stopped and it lands on a shed that's 3 meters high. So our y final equals 3.00 meters. We're also told that our initial velocity, so this is the magnitude of the initial velocity, is 52.0 meters per second. And this angle here is 42.0 degrees. So this is all that we have here, and we want to find the time. Let's look at our equations and see what we can do here. We don't know the final velocity. We do know the change in height. We know the initial velocity, and we know that the acceleration, of course, is just going to be g. And that's negative 9.81 meters per second squared. So we can go ahead and use this top equation, but for the y component. So we do need to break our velocity up into the x and y components. So our v initial in the x direction is going to be v initial, so this given velocity is our v initial, times the cosine of the angle. And then v initial in the y direction is going to be the initial sine of theta, where of course this is our vix, this is viy. So we can plug this into the kinematic equation that we have. So let's go ahead and write that out. So we're using the change in the height. So we have delta y equals v initial y times t. And then we're plugging in g, so that's going to be minus 1/2 g t squared. G is negative. And then, so delta y does mean y final minus y initial. Our initial y component is just 0, right? It's on the ground. So here, what we actually have is just y final. So y final equals v initial times sine of theta times t minus 1/2 g t squared. Normally, I don't plug in the values until the end of the problem because it helps us to understand what we're doing and we're less likely to make mistakes doing it that way. However, we're going to need to look at a quadratic equation. So let's go ahead and make this into a quadratic equation. So y final is 3.00 meters, and then we have v initial, which is 52.0 meters per second times the sine of 42 degrees times t, so we don't know t, we're leaving that. And then we have minus 1/2 times 9.81 meters per second squared times t squared. Now, simplifying this, and then I'm also going to just subtract 3 meters to the other side so that we have 0 over here. So minus 3 meters. And I'm also just for simplicity, leaving the units off, another thing I don't normally do, but we need to look at this as a particular type of equation. So for now, I am just going to leave the units off of here. And then we have, so multiplying 52 by the sine of 42 degrees, we get 34.8 t. And then we have minus, so 1/2 times 9.81 is 4.91 t squared. So here we have a quadratic equation. We have a value times t squared, and then we're adding a value times t, and then a constant. So now we're just going to go back and remind ourselves of something we should have learned in an algebra class, a very important part of an algebra class. So quadratic equation looks like this. So a x squared plus bx plus c equals 0. So this is a quadratic equation, and this is what we have here, but instead of x we have t. So we have to solve this quadratic equation, and the way we would do that is to just use the quadratic formula. So remember that is x equals negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. So in our problem, we have the value that is multiplied by t squared is our a, this is our b, and this is our c. So we need to plug this in an equation like our quadratic formula to solve for t. So I'm just going to move this up. I'm going to say t is equal to, so minus b squared, b is 34.8, or minus b, which is 34.8, plus or minus the square root of 34.8 squared minus 4 times a, which is negative 4.91, times c, which is negative 3. And then this is divided by 2 times a, negative 4.91. Okay, so now we just have to go through this twice, once where we add the square root of 34.8 squared minus 4ac, and then one where we subtract it. So if you're not doing this during a test, you could just look up a quadratic solver and plug in your a, b, and c values. They'll give you the two answers. I would double check it. I usually do. Or you can just actually go through and do the math by yourself. It's really not that hard. At this point, you have everything there for you. But the two values that we get for this equation are going to be 7.00 seconds or 0.0873 seconds. So these just both have 3 significant figures like the other values. Okay, so obviously we can't have 2 answers when we're asked how long it takes for something to happen. What is going on here is you're getting the 2 different times that your object is at the 3-meter mark, right? So that's going to be at the end here. And then when it reaches 3 meters right after being launched. So there are 2 different times it's going to be at 3 meters. This question is asking how long the object is in the air. So we want the one that's at the end, right? So that's going to be the one that's bigger or longer. So our answer here is t equals 7 seconds. And so that's how you would approach these types of problems. And you're going to end up with this problem when you have a delta y that is non-zero. So when the object doesn't land at the same height that it started off at, and then you're asked for the time.